Today we're going to be talking about the embryology of the male reproductive tract, especially of the development of the testes. Now I'm going to break it down extremely simple so that if you have no idea what embryology or development of the testes, or have you no idea and never seen any of this before, you will completely understand it, I promise, at the end of the video. And don't, as usual, don't let any of this scare you. We're going to go through it step by step and you'll understand everything. So the development of the testes is closely linked to the development of the kidneys as well. I have a kidney embryology video that's very easy to understand as well, so it might be a good idea to have a look at that one before we have a look at this. But I'm going to go through a little bit of the embryology of the kidney as well, just so that you can put all the pieces together and fully understand what's going on. Okay, we're going to start right at the beginning with fertilization. So, a sperm and an oocyte join. The oocyte is fertilized and then they form this ball of cells called a blastula. And this blastula undergoes gastrulation to form the 3 germ layers. Now, if you have no idea what embryology is, you probably, but you want to know what embryology is and you've read up a little bit about it, you've probably seen these 3 layers around. You might not understand what it is, but let's go through it. There's 3 layers. First, the ectoderm, the outer layer, the mesoderm, which is the middle layer, and the endoderm, which is the middle layer. I mean the inner layer, that's right. So you're probably wondering, how is this the inner layer and that's the middle layer when it's 3 layers that are straight? That's because initially that's how everyone starts out, in these 3 layers just like that. So what happens is that it ends up folding and the outer layer becomes your skin and the inner layer becomes your intestines. That's to break it down very simply. So this is an oversimplification for this. So over here we have the ectoderm. This in red we have the mesoderm. And in green we have the endoderm. And this right here is a cross section of the fetus. So if you are still confused by that, just picture a fetus with a cross section and it's still in its trigeminal layer form. This would be the amniotic sac and this would be the yolk sac. Okay, so from when you get fertilized and you have the blastula, at this stage we're on day 17 and it's just as simple as it continues to fold. It's continuing to evolve. Picture it like it's a Pokemon that's just evolving through its stages. So on day 17 we have this, and on day 20 we have this, and then on day 21 we have this. Now, just don't let that scare you. What happens is that the ectoderm folds and pinches off to form a neural tube. The mesoderm, continues to differentiate and forms 3 sets of mesoderm, which we will go through. And the endoderm will eventually become the primitive gut. Okay, the focus of this video will be the mesoderm, the middle layer, because that's where the kidneys and the gonads originate from. That's where they are developed from. So let's get straight into it now. Okay, having a look up at here, in blue we have the ectoderm again, the neural tube, the endoderm, and in red and purple we have the mesoderm. Now let's focus on the mesoderm. This larger bit of mesoderm, that's the paraxial mesoderm. And these will form things like smooth muscle, skeletal muscle. This middle in purple that I have colored in, that's the intermediate mesoderm, and that is where the kidneys and the gonads arise from. That's where the testes come from. That's why I have colored in purple to outline this. So, and it's called the intermediate mesoderm. And then we have the lateral plates. These are the lateral plate mesoderm. Okay, now the focus is going to be on this purple right here. This is where the testes and kidneys come from. Okay, now, this being a cross-section of the embryo, over here we have a longitudinal view. So if we take this and kind of flip it up like this, we will have intermediate mesoderm right here. Now don't let that scare you, we're going to go through that. This is intermediate mesoderm, and this is what's going to form the kidneys and the testes. So this, being a longitudinal view, isn't a single snapshot in time. It's a combination of different times, and eventually will form the kidneys and the gonads. Let's just go through that. So we have 3 stages of kidney and gonad development. Initially we have the pronephros, which is in red. And that's the initial structure of the kidney. This is your first kidney, and it's rudimentary. It won't be there for long. It'll eventually degenerate and will be replaced by mesonephros. Okay. So as the mesonephros is developed, the pronephros is degenerated away. So just picture it like it's developing like this, and by 4 weeks we'll have the pronephros and the mesonephros developing, and as it's developing, the pronephros is gone. Okay, so in green we have the nephrogenic cord. That's mesenchyme, it's just tissue. And that will also become kidney and gonad. Over here at the bottom, we have, so as it develops in a cranial to caudal direction, we have this metanephric diverticulum forming, and this is what will become the adult kidney. Over here we have the mesonephric duct. This is also an intermediate form of a kidney in the developing fetus, and this is what will become the testes eventually. And over here we have the mesonephric tubule. Which will also become part of the testes, but initially right now is the intermediate form of the kidney. Another name for this is the Wolffian duct and the Wolffian tubule. And over here we have the cloaca, and its posterior portion will eventually become the anus, and its anterior portion will become the urogenital sinus. Okay. That's enough about the kidneys, but it is very important to know about this before we get into the testes. Okay, let's have a look at this fetus over here. In yellow, we have the primitive gut. In green, we have the same green over here, so the nephrogenic cord. The red up here is the rudimentary kidney, so it's the pronephros that's degenerating. In black over here, that's the mesonephric duct. And over here, that's the formation of the kidney. So having the metanephric diverticulum over here, we'll have the developing kidney here, and this will be the final form of the kidney. So the most important part to look at for here, though, in relation to the gonads, is right here in the mesonephric in the nephrogenic cord. This is because cells from the germ cells are starting to migrate now. So what happens is that the germ cells migrate from the epiblast and cover up, form a genital ridge right above the epithelial cells of the nephrogenic cord. Okay? So in the meanwhile, as the cells are migrating, the epithelial cells of the nephrogenic cord are proliferating. So it's getting thicker in preparation for it, and the germ cells, together with the hypertrophy of the epithelial cells of the nephrogenic cord, will form this gonadal ridge or the genital ridge. So how do these germ cells actually migrate to this location? So the mechanism isn't fully 100% understood how, but it's through this process called amoebic movement. So the actual cells themselves kind of are moving their cytoplasm and crawling to the location under the influence of molecular directions. Other than that, I think that's enough of information that you need to understand what's going on. Any deeper than that, and you can do your own PhD in this. So moving on, the germ cells follow down through the hindgut into the dorsal mesentery, and then follow up and go up to the gonadal ridge at the nephrogenic cord. Okay, to understand this a little bit more, let's have a look at this now. Okay, let us make a section through here. So cross-section that, flip it, we'll have this. So this slice here, and we're looking down from this direction. And you'll see this, okay? Just focus only on this. So we have in yellow here, that is the primitive gut. This to this is the urogenital ridge. And this in thick red, that's the genital ridge or the gonadal ridge. So this is right there. That primitive gut is this yellow part here. And over here in blue, we have the mesonephric duct. Whoops, sorry, not that one. And in green, we have the paramesonephric duct. Okay, so the paramesonephric duct, that's going to eventually become the ovaries and the fallopian tubes, and the mesonephric duct is going to eventually become the epididymis, etc. So what I'm trying to say here is at this point, we have the indifferent gonad. So initially, every human begins with both of these structures, and the genetic determinants make the decision on whether or not it's going to be a female. So at fertilization, you either have the X and the Y chromosome, or you have the X and the X sex chromosome. So it's determined what sex you'll be at fertilization. But it is at this point, and it's driven by hormones, that determines if the actual sex differentiation will really occur. So let's go through that. Over here we have the germ cells migrating, and as they migrate, the epithelial cells of the nephrogenic cord are growing, forming the primitive sex cords. And the germ cells form on top, developing the testes. Okay. Now again, let's switch back to a longitudinal view down here. So we're only looking at one of them now. So let's look at this one longitudinally. Over here we have the mesonephric core, the mesonephric tubule, and the mesonephric duct. And this is the paramesonephric duct, also known as the Müllerian duct. Also, as these are differentiating, you'll form the septa of the testes, the tunica albergini, the seminiferous cords, and the reta testes. So these are the beginnings of the ductal system of the testes. Okay. Initially, again, every fetus has both the Müllerian ducts and the Wolffian ducts, or the paramesonephric ducts and the mesonephric tubules. So, how does it become a male? Under the influence of genes, for the most important one being SRY, sex determining region on the Y gene, and COX-9, they are the signals for the development of the testes. Sex determining region Y, COX-9, and steroid genesis factor 1 lead to the secretion of anti-Müllerian hormone, which leads to the destruction of the Müllerian duct. So that's one. Again, the SOX9 and the steroid genesis factor 1 gene lead to the secretion of anti-Müllerian hormone, which leads to the destruction of the Müllerian duct. Also, under the influence of sex determining region Y and COX-9, you'll have the mesonephric tubules forming an efferent tubule and integrating itself with the reta testes, as well as the mesonephric ducts, forming the epididymis and the mesonephric duct. So what happens is, as this degenerates, this mesonephric duct will form eventually form the Ductus Deferens. Okay? So it's very important to know that although initially you'd have either the X and the X or the X and the Y chromosome, X and the Y, which will be the genetic, the determining factor if you're going to be a male, it is at this stage where the differentiation actually occurs, and without this process, with these genes and these hormones being involved, then the development of the testes will never occur, and you can have a lot of pathologies of the testes. Okay, so this is keeping it as simple as possible. I just want to run through everything very quickly again before we talk about the actual testes dropping down in all the way. So we have in fertilization forming the 3 germ layers, and it is in the mesoderm that the kidneys and the testes are derived, in the intermediate mesoderm. So the kidneys develop, and this whole structure, which will be the kidneys and the gonads, will develop cranially to caudally. So as it grows, the top degenerates, and the adult structures are left at the bottom. So at this metanephric diverticulum, this is where the kidneys will eventually be. We have the germ cell migration from the epiblast, which will find its way all the way to the nephrogenic cord and bind itself to the gonadal ridge, which is the proliferation of the nephrogenic cord. And this is the development of the testes and the seminiferous cords, septa, and the rest of the testes. So with that being said, the seminiferous cords are cords rather than tubules at this moment, because it's not until puberty that the lumen actually is developed. So it remains a thick cord until puberty. That's why we call them seminiferous cords and not tubules. Okay, additionally, we'll have the degeneration of the paramesonephric duct and the development of the Ductus Deferens from the mesonephric duct. The mesonephric tubules, under the influence of SRY and COX-9, will integrate itself into the rete testis, forming also the epididymis, more dilatation and of the mesonephric duct. And the degeneration of the paramesonephric duct, or the Müllerian duct, is under the influence of anti-Müllerian hormone, which is secreted by SOX9 and steroidogenesis factor 1. We have the testes, the ductus deferens, and the urinary bladder, as well as the gubernaculum. Now, the gubernaculum's function is to aid in the descent of both ovaries and testes. They have no function in adulthood, they're completely gone. So the gubernaculum aids in the descent of the testes and the ovaries, and it's as simple as it moving down to forming this. That's as much detail as I'm going to go in for this video. In the next video, in a future video, we will go through the external genital development. I've also have an embryology of the heart video coming with septation and a little bit more advanced embryology of the heart that you guys have suggested. Yeah, please leave a comment and like the video, share it, join the Facebook group so you can ask any questions that you want, and I'll answer all of the questions that you ask me on Facebook, and I read all of your comments as well. Thank you very much, guys. Have a great day.